Hi everybody, in this video I want to just demonstrate the law of large numbers at work here by choosing a random sample of individuals from an underlying population. And so suppose we have a data set and we have in this population of 78 people, n equals 78, we have a proportion of females with 34%. So if 1 is equal to female, 0 is equal to male, and out of this 78 person population, the proportion of females is 34%. And so what I've done here is I've just taken a random sample of individuals using a formula here in Excel. And if I hit F9, this formula will refresh itself every time. And so it's going to take a random sample, and from that number, it's going to determine whether they are a male or a female. And up here, we're going to see the proportion of females. So as you can see right now, there's a 60% proportion of females. I'm going to hit F9 a few times. Okay, in this sample, in this draw, everyone was a male, and so 0% females. This one 20% females, 20%, 40%, 60%, 20%. So as we just continue taking samples, we see that there's a lot of variation here. So let's up the sample size to 10. Okay, so again, same thing, random formula to take 10 random IDs, and then we're going to look at the proportion of females. And so 50%, 30%, 40%, 50%, 60%, right, so on and so forth. Let's up the sample again. And now we have 30. So our sample size is getting a bit larger. Not quite half of the population. But even with a sample size of 30, we see that we're much closer to the underlying population. So 34% versus 36, right? 43, 26, 36. And so as you see, the numbers, there's still some variation there. It's unlikely that it's going to be perfect every time, but you see, especially compared to these other sample sizes, we're getting much closer to the underlying population. And then finally, I'll do one more within a sample size of 60. So we're at 36%, 33, 38, 33, 38, 33, 30, 40. But you see we're really honing in on, as our sample size increases and gets closer to the underlying population. Really, once you start getting above 30 for most data sets, you're going to start seeing similar sample sizes for individuals in the sample relative to the population. And again, like I showed in the last video, the beauty of this is that this is not only true for, say, the proportion of females, but let's suppose that this was a proportion of, ability, and it was high-low, and we had 34% of the people had a high ability, and the rest had a low ability. Again, for even unobservable characteristics, as the sample size increases, it's going to approach the underlying population. That's true of observable characteristics, unobservable characteristics, and that's why random sampling is kind of the gold standard when it comes to looking at causal effects. So what you would do, if you had enough in a population, so here, for example, you've got 78 people, you could take 30 of them and randomly assign 30 into a treatment group. That those 30 individuals, the 30 people in that sample are going to be fairly resemblant of what we have in the population. You take another 30 individuals, again, randomly into both groups, and the treatment group is also going to have a similar composition to the population. So across all observable and unobservable characteristics, you're going to have 30 people in each group that look not only similar to each other, they look similar to the underlying population. And again, the only difference between the people in those two groups is going to be one receives a treatment and one does not. And so you're really going to be able to get a nice causal effect when you observe what happens to the people who get the treatment. Okay, and that was this idea here. Everybody is observable. Random assignment combined with law of large numbers removes selection bias by ensuring the mix of individuals being compared is the same. So if this is our underlying population with all their observable, unobservable characteristics, everything in a random sample from both looks the same, except one gets a treatment, one does not. So you take that, and then all you have to do is look at summary statistics. You don't have to do any fancy regressions or anything like that. You look at summary statistics, you see what was the effect of the people in the treatment, what was the effect of the people in the control, and the difference between those two is going to be the causal effect of whatever that treatment was. Okay, so again, just wanted to demonstrate the power here of larger samples. 30 is generally kind of a rule of thumb that some people use, but again, the higher the number, the better. Okay, thanks everybody. This is going to be it for this video, and I'll continue in the next with some more examples of random assignment used in practice. All right, thanks.